Thanks for joining us across the fence. I'm Keith Silva. Perhaps you've noticed these structures popping up on the landscape. To the uninitiated, they look like greenhouses, but farmers refer to them as hoop houses or high tunnels. They are unheated buildings, which is why they're not greenhouses, and they can be temporary or permanent. High tunnels give farmers time to extend the growing season, which improves the bottom line, but these structures also create an environment for pests and pathogens to thrive even in the dead of winter. Today we're going to learn about a technique more and more vegetable farmers in the Northeast are using to make high tunnels hot stuff. The growing season is heating up at Singing Cedars farmstead in Orwell.
Today we're soil steaming. Yeah, so there's a white side and a black side. The white side's going to be on the top now.
Got it.
Becky Madden runs the farm with her husband Scott. She also works for UVM Extension as a vegetable nutrient management specialist.
We have 8 high tunnels, 3 of which have heat in them, so I guess technically they'd be considered a greenhouse to some degree. High tunnels generally mean you're growing in the soil in an unheated structure. And because we're organic, we grow in the soil and with organic systems.
All summer, these high tunnels have been stuffed with tomato plants that stretch from floor to ceiling. Fall means the tomatoes are out and the winter greens are in.
The timeline for establishing winter greens, I think for a lot of farms, it's a pinch point in terms of labor. We're treading the line where we're still harvesting tomatoes and still gaining income on them, and then suddenly you're like, we got to get the greens in. This tunnel was full of tomatoes, and today it's completely ripped out, clean soil, bare soil. We'll have it planted out probably by next week. We plant spinach, lettuces, kales, all sorts of different yummy winter vegetables. Around the same time we do that though, chickweed, which is a winter annual weed, will germinate and outcompete a lot of our greens. And after a couple years, it's become a really big problem to the degree that I think 3 or 4 years ago we lost entire crops. It just really smothered them.
You may have seen chickweed. For farmers who grow in high tunnels, it's an ever-present nuisance.
It's very hard to weed. Like a lot of weeds, it pushes out a lot of seed. The seed viability is very long, and we don't do mechanical cultivation in tunnels, but it's just got a very fibrous root system and is really just challenging to pull out.
Every farm's economics are different. There are a lot of factors to balance in order to stay profitable. For instance, is it worth paying someone to hand weed? Can losses be made up by the market? Soil steaming is a popular and tried and true technique for eradicating weed seeds. Maden's efforts are aimed at fine-tuning this technique for the specific purpose of growing crops in high tunnels.
We completely clear everything out, try to eliminate all the vegetation, and then we'll spread out a tarp on the soil. Underneath that tarp is what's called a sock, a steam sock. It's like a fire hose. It's about 4 inches in diameter, and you run it down the length of the bed, and the tarp is secured with chains. It's tight and it inflates a little bit, and then the steam kind of hits the top of the tarp and then penetrates the soil. And if the soil moisture is perfect, that steam should evenly work its way through it. We're trying to only steam down to 2 inches, and theoretically below that, the soil biology can kind of stay intact.
Soil steaming has been used by vegetable growers and at flower nurseries for years to kill weeds and pathogens in soil, but its effectiveness has not been studied in high tunnel vegetable production. This is the 3rd year of a grant Maden received from the USDA and the Vermont Department of Agriculture. So far, this project has been full steam ahead, so to speak.
Yes, it works. It's not just killing chickweed and other weed seeds, it's also eliminating Pythium, which is just kind of a ubiquitous root rot fungus in the soil, so it knocks that out. Soil steaming releases nitrate, which is available nitrogen from organically bound forms, and that's been one of the huge bonuses. People are seeing a great yield bump from the steaming process. So it's basically immediately available fertilizer that in an organic system we don't tend to see that kind of burst. And because the weather's cool, day length is dropping, usually winter greens kind of peter along. So in our side-by-side trials the first year, I was like, wow, that's crazy. This bright green lush spinach next to pokey little,
Spinach.
what we're used to. Yeah, we had to dial back our seeding rate after the first year, because we were so used to overseeding and losing half of it to Pythium and a bunch of it to chickweed.
The steam eliminates most of, if not all, the weed seeds and other disease-causing plant pathogens. The question is, what's happening to the rest of the soil?
If you're killing the chickweed, what's happening to everything else? In order to answer that question, we took on this trial. Soil biology is a very hard thing to measure. I'm working with Deb Neer's lab up in plant and soil science.
Becky Madden came to me one day and she was describing her interest in using steaming for weed seeds. I informed her, this is really not a very novel technique necessarily. And my experience in plant pathology, I know that greenhouse industry has been using this for decades. What we realized was really novel was how it's being applied in this case, in terms of going with the high tunnels, because they have soil that's there all the time. And so they have to have some way to manage it. And you want to do it a way you don't have to use chemicals.
Rachel Elliott is an undergraduate working in Neer's lab. Her job is to test Maden soil samples and record the results.
And this machine shoots a little laser through the middle to take the readings.
The color blue on this chart indicates microbial activity. The darker the blue, the more activity. A good sign that matches Neer's hypothesis.
We see changes, so it's as I predicted, but it's not a detrimental thing. It's a short-lived, it's kind of as I would expect. I think it has promise here for use in Vermont.
We have 8 tunnels now, we're building 2 more. So as we scale up, we want to mechanize. And mechanize means having a more uniform stand and not having, if you're cutting by hand, you can work your way around weeds, but on a larger scale, that's something we're working our way towards. And so as this industry builds and the markets build, we need ways to kind of scale up. So we've created this environment in these tunnels. For my work with UVM Extension, I've spent a lot of time on high tunnel fertility, particularly for tomatoes, which is a summer crop, and it's all about like boosting your nitrogen and potassium, which interestingly is exactly what chickweed thrives in. So we've created this ideal environment for it to really take off.
To borrow a phrase, into each life a little rain, or in this case, steam, must fall. The cost of the equipment can be expensive, not to mention the cost of the fuel to run it.
This is a $30,000 piece of equipment, not really feasible for most farms here, and you only use it a couple of days of the year. To put it in perspective, it takes about 55 gallons of fuel, diesel or kerosene, to do a 30 by 90 house. So one standard high tunnel. Wow. That's like kind of more than we use on our farm all year here. We don't use a lot of fuel and tractors. And you multiply that out to, if we were to do all 8 tunnels, it becomes a little bit staggering. I think our job at UVM is to kind of spend the time doing the research, but also connecting with the other people doing this. It's funny, sometimes with Extension, I think that's what we're doing is taking farmers' questions, researching them, coming up with data, and then as we present the data, they're like, well, yeah, I mean, that's what I've observed.
I love talking to farmers. They're the ones that really generate my research ideas, because I say, what are your main problems? What are you struggling with? My ideal research project is one that you learn some basic biology, but you have an application. So there's always that application that fits very much with the outreach land grant mission. They tell me their stories, which I, think of as anecdotal information. And so I feel like my role is to try to understand how and why that happens. And if that's a general thing, but that's the science part is learning how and why.
As high tunnels continue to rise in Vermont, so too will the challenges they present. The same can be said for the researchers from UVM who will have to rise to meet those challenges. Joining me over Zoom is Becky Madden. We're recording this in early October. Have the hoop houses been steam cleaned, Becky?
Hi, Keith. Well, I hate to disappoint our audience, but we did not steam this year, and that was mostly for other circumstances with a really tight growing season and all the rain. And also, I think some of the outcomes from this research have helped me learn that it's not something we need to do every year, and just balancing out some of the costs we talked about in the in the video clip you just showed, balancing out our fuel use and expenses with the outcomes. So we took a break this year.
When I reported the story last year, you were in the final year of researching the effectiveness of steaming. So what have you learned besides maybe you don't have to do it every year?
I've learned a lot from this project. I've learned the ingenuity of farmers is really rising to the top. So even in the time lag since we spoke last year, there's been some great work done by farmers who are really involved in the industry of steaming more heavily than myself. We're looking at reducing that fuel use and improving the efficiency of the technology. As Deb mentioned, it's a pretty old and crude way of managing this problem, actually. So that is coming along, and I think that's very exciting. I've stayed engaged with their conversations and presentations. I've learned that the soil biology thing is not a concern, which is very reassuring. You said it, all the other cost benefits aside, you cannot worry about the soil biology in the long term.
Right.
I've learned that it works. It's really the only thing that works for chickweed as far as I can tell. So that is kind of what it boils down to for me.
We've got a graphic that our director, Brock Sutterfield, can put up that shows microbial activity, and the steaming does what it's supposed to do. Those microbes, the good bugs in the soil, bounce back. They came back and were not affected by the steaming, if I'm reading this correctly, Becky.
Yeah, exactly. And that's what you're looking at there is the average metabolic response. So it's the overall population crashing and then coming back up. So you're not really seeing like good guys, bad guys in there, but we want that population there
to rise.
Yeah, and the other thing Deb helped us look at, and this is like a total broad brush, like not super sciencey approach. The other thing Deb helped us look at was the community diversity, and that also climbed back up again. So two things is overall numbers and then the diversity, and both of those came back up.
Well, good news on both those fronts there. Becky, thank you very much. And I also want to thank everyone here at WCAX for making this program possible, and remind you, if you missed a portion of today's program or you just want to watch it again, you can find us on YouTube or Facebook by searching Across the Fence. Take care.